Today, Group 1 is going to explain about Bernoulli principle. Bernoulli principle states that the total mechanical energy of a moving fluid comprising the gravitational potential energy of elevation, the energy associated with the fluid pressure, and the kinetic energy of the fluid motion remains constant. Bernoulli principle can be derived from the principle of conservation of energy. In simple terms, if the motion of the fluid increases, the pressure of the fluid will decrease. It is formulated by Daniel Bernoulli, although Leonard Euler, who derived Bernoulli equation in his usual form in the year 1752. There are several factors affecting the Bernoulli's principle. First of all, the cross-sectional area. The cross-sectional area is inversely proportional towards fluid dynamic pressure. As the area increases, the pressure decreases to maintain constant force through the line. The kinetic energy of the fluid also decreases according to the principle of energy. Therefore, the velocity will increase. If the area decreases, the pressure increases, so the velocity will decrease. Apart from that, fluid velocity also one of the factors which affecting the Bernoulli principle. Fluid velocity is inversely proportional towards fluid pressure. As the fluid velocity increases, the kinetic energy of the fluid also increases. And according to the principle of conservation of energy, this increase in kinetic energy is balanced by a decrease in pressure. If the fluid is fallen from a certain height, there will be potential energy which will be converted into the kinetic energy. Therefore, the velocity will increase. Last but not least, we are going to talk about fluid density. Fluid density is directly proportional to fluid dynamic pressure. According to the Boyle's law, the volume increase causes it to increase the pressure. As the pressure increases, the kinetic energy of the fluid also decreases according to the principle of energy. Now we are going to talk about application of Bernoulli's principle. First of all, it is affect the air flight. It is because an aeroplane wing or airfoil is designed with a particular shape that influences the air flow over and under the wing. The cross-sectional shape of a wing, which is typically curved on the top and flatter on the bottom, creates difference in airspeed and pressure essential for generating lift. It is because differences in the pressure, lower pressure on top. According to the Bernoulli principle, the faster moving air over the top surface of the wing results in lower pressure. Higher pressure on bottom, the slower moving air under the wing results in higher pressure. Next, the baseball. The force exerted on a spinning ball moving through the air. Air velocity on one side of the ball which causes spin causes the air to move faster relative to the ball's surface. On the opposite side, the spin causes the air to move slower. According to the Bernoulli principle, the faster moving air causes higher lower pressure, which is responsible for the curved trajectories of pitches, or it is known as Magnus effect. Next, we are going to talk about water jet. When the water is coming out of the nozzle, the water velocity is very fast, which causes it to decrease in pressure for the propulsion, where the kinetic energy from the fast moving fluid is causing the pressure to decrease.
For this experiment, we're going to use 3 plastic bottles, a Bunsen burner, 3 nails with different size, water and oil, a duct tape and a marker pen, and lastly a measuring cylinder. First of all, measure 200 ml water by using a measuring cylinder.
Then pour it into the water bottle and mark it using the marker pen. Repeat this step until the water level is 1000 ml. Then heat up the nails and poke a hole with 3 different sizes for 3 different bottles at the 200 ml water level. Pour 1000 ml of water into the bottle that has been taped. Remove the tape and start the timer. The time was recorded for every 200 ml reduce of water. The same step was repeated by using oil.